And we're starting with our webinar. Welcome everyone to our webinar on farmers' rights, how complementarity between researchers and farmers impact the conservation of genetic diversity, food security, and livelihoods of the poor. I'm happy to join you today from a nice and sunny autumn day here in Rome, sitting in front of an open window this morning. As I was doing the last preparations for the webinar, I realized how extraordinary these occasions really are, where we can use technology to connect dozens and dozens of people worldwide in real time. And we had about 160 people subscribing for this webinar spanning the globe. So if you think of it, it's really extraordinary what technology allows us to do, despite that it is always a challenge for us, especially during real-time live events. I was also kind of contemplating this morning about how extraordinary it is for dozens of people who have never met before to share 2 hours of their lives and their time on something which is of common cause and common interest. And today it's on farmers' rights and the link between the complementarity between researchers and farmers. As for any and all of our webinars, this is the fruit of a collaboration between GFAR, the Global Forum on Agriculture Research and Innovation, who is facilitating this webinar, and several of our partners. Today's webinar comes to fruition as an initiative between CGIAR, the Global Research Partnership for a food secure future. And today also we have 2 speakers from CGIAR research centers. It was also in cooperation with Asociación and GODAN, the Global Open Data Initiative for Agriculture and Nutrition. So this webinar is really a collective action or a collaborative project between our partners, with GFAR being merely the oil in the machinery. During this webinar, the man behind the scene is Charles Plummer, and you will probably hear me shouting out to him, Charles, mute him. Charles is my partner in crime, and he manages the slides and the technical aspects of this webinar. My name is Peter Cazier, and I will be moderating your questions. I have the honor of introducing the speakers. Charles and I and Juanita, one of our speakers, both work for, all 3 of us work for the GFAR Secretariat. And we manage, with Charles, I manage the social media and online media channels and outreach projects. Now, before we start, our usual word on the logistics of this webinar. For this webinar, we are all connecting through a service called BlueJeans, which allows everyone to see the presentation and those speakers with a webcam. Feedback, tips, and questions should only be done via the chat box. So please mute your video and audio and keep it muted. Otherwise, it will suck up a lot of bandwidth from everyone. Even though we are a big group, we had about 160, 170 registrations for this webinar. I would still like this session to be as interactive as possible. So I do encourage you to send remarks, suggestions, and questions during the presentations already using the chat box. It's the icon which you can find on the top right-hand side of your window. During the webinar, we will not have Q&A break, so we'll do one presentation after the other, but we'll have a 20 minutes or 30 minutes break at the end of all of the presentations. So if you have a question or suggestion that pops up in your mind, just type it right in the chat box. I'll collect them and we'll go over them during the Q&A break. After this webinar, I will also send you a link to the recording of the webinar, a link to the presentation file, and some links to websites or resources we might have mentioned during the webinar itself, or answers to questions we will have not covered during the webinar itself. Just we can go to the next slide. Today, I'll hand off to Juanita Chavez, who is also working for the GFAR Secretariat, who will introduce the topic for today. Then we'll continue with Jorge, who works for CIP, the International Potato Center in Peru. Then we'll switch over to Kampala, Uganda, for Rose Nankia, who works for Biodiversity International. Next speaker is Alejandro Argumedo, who works for Asociación Andes, also joining us from Peru. And last but not least, we have Jeremy Barbie, who works for GODAN, the Global Open Data Initiative for Agriculture and Nutrition. And then we'll have the last part, the Q&A session. So let's get this show on the road to kick off. Allow me to introduce our first speaker. We'll also introduce the topic, Juanita Chavez, who is working on pulling this webinar together. Gonita, you can already unmute audio and video at the moment. Gonita is a lawyer with more than 10 years experience on access to genetic resources and benefit sharing. She worked for the Secretariat of the International Treaty on Plant Genetic Resources for Food and Agriculture for 5 years, and currently is a senior advisor for the GFAR Secretariat on Genetic Resources, Intellectual Property Rights, and Farmers' Rights. She coordinates the Joint Capacity Building Program with the treaty and other organizations on the implementation of farmers' rights. Gonita, the floor is yours. Go ahead.
Thank you very much, Peter, and good morning to everybody from Bogota. We also have a very nice day today, so I guess we will be inspiring for this webinar. And welcome to everybody who is participating today with us. Next, please. I would just like to maybe note that this webinar could be considered as a complement and a continuation of a first GFAR's webinar on farmers' rights that we held in May this year on how to achieve complementarity between the informal and formal seed systems. During that webinar, a very good introduction was made, and now we will have concrete examples on how complementarity and in particularly about the process that farmers and researchers have been undertaking to achieve that joint and complementarity activities. And I think the process on how to build trust between the stakeholders to increase capacity building is crucial if we want to replicate and upscale lessons learned and statistics and success stories. In addition, I think it's important to recall that the International Treaty on Plant Genetic Resources for Food and Agriculture of FAO acknowledged the contribution of farmers in conserving, improving, and making available crop genetic resources and aims to support these farmers in managing and conserving crop diversity in their farms. It is the only international treaty recognizing farmers' rights which are based in this recognition. The treaty requests contracting parties to take measures to ensure that farmers who have been conserving and further improving plant genetic resources receive full recognition and financial support to continue their valuable work. This includes measures, for example, protecting traditional knowledge relevant to crop diversity, the right to participate in benefits that may arise from using crop genetic material, and the right to participate in relevant national decision-making processes. It's very important to keep in mind that according to the international treaty, the responsibility for realizing farmers' rights rests in national governments. Therefore, it is not a responsibility of the CGIAR centers. However, researchers who are daily working with smallholder farmers in the fields are promoting farmers to keep conserving and improving plant genetic resources, ensuring food and nutrition security, and also improving the livelihoods of these local communities. And in other words, researchers can support promoting farmers' rights, and in some cases, supporting improving its recognition and realization at national level. Next, please. So I would just like to remind us the objective of this webinar, which is to exchange information, best practices, and concrete examples on how complementarity between the formal and informal seed systems is being achieved in practice by researcher communities and smallholder farmers in developing countries. So we will have examples in Africa and in Peru in this webinar. And finally, and very important in how open access to research data can directly or indirectly impact smallholder farmers and food security. Next, please. So we will expect, of course, that you find this webinar interesting and useful after the exchange of information and success stories and best practices. But also identify challenges and possible solutions. And we would like at the end that you participants get motivated, identifying ways and tools to exchange your experiences and best practices towards achieving this complementarity in practice between the formal and informal seed systems, and find way to exchange and promote your work and improve your collective actions in the field. Thank you. I think that's it. Yeah, thank you very much, and good luck with this with the discussion.
Excellent, Junita. You can go on audio and video mute. Jorge, you can unmute, so you're ready for your presentation. Thanks for the introduction, Juanita. Our next speaker is Jorge Andrade, who holds a PhD in the plant pathology with minors in the epidemiology and international agriculture from Cornell University. He has a master's in plant pathology from La Molina University and a bachelor in agronomy from the Central University in Quito. Jorge had postdoctoral studies in the International Potato Center, SIP. He is a member of the American Phytopathological Society and the Latin America Phytopathological Society and the Latin American Potato Society. Jorge has 15 years of experience in research and development with small-scale potato farmers in Andes. His research interests include the epidemiology of the potato late blight, seed systems, agile education, and innovation systems. I see you online and unmuted. You're all ready. Jorge, the next 20 minutes are yours. Go ahead.
Thank you very much. Hello, everyone. My name is Jorge Andrade. I'm located here in Lima. I'm a scientist in the International Potato Center. And thanks for having me. I think it's a nice opportunity to share some of the experiences that we have here in SIP. So the title of my presentation is Informal and Formal Seed Systems. Let's see, informal and formal potato seed systems in Peru, a technical perspective for improving seed quality. So you saw you just heard my background is in plant pathology. So I'm going to describe some perspectives from a technical side. So you will see, let's continue to the next one. Oh, the outline is okay. So I will provide some background first. I will describe a little bit the potato sector here in Peru. I will provide some basic concepts about seed degeneration, which is very important in clonally propagated crops such as potato. And then I will describe a strategy that SIP and partners are developing, which is called the Integrated Seed Health Strategy, in which we have three components. The first one is host resistance, the second one is on-farm seed management, and the third one is use of clean seed. And I will finish my presentation with the main message that I want you to communicate to you. Next one, please. So the background, potatoes in Peru are critically important. Peru is the #1 potato producer now in South America. Most of the production is done by low-scale farmers. We are talking about thousands of farmers, especially in the highlands and also in the coast of Peru. So it's a very important crop here. It's the #1 crop here in Peru. The production is done mainly in the Andes, so we have a huge climatic and soil variability. In this picture, in the right, you can see a valley and a mountain. So the difference in temperature, for example, in the bottom of the valley, as compared to the highlands, can be 3-4 degrees, and also huge variability in soil conditions. And at the same time, potato was born here in Peru. Well, in Peru and Bolivia, in the Titicaca Valley area. So there is a huge biodiversity here of potato. We are talking about more than 4,000 varieties of native varieties. So this is the context of potato here in Peru, a crop critically important for food security. Yeah, next one, please. So in Peru, we are living what's called a potato boom. Okay, the production has increased from 3.3 million tons per year in 2000 to around 4.7 million tons per year in 2013. So it's a huge increase. Also, the consumption This has increased from almost 75 kilos person per year in 2007 to 82, almost 83 kilos person per year in 2011. And also yield has increased from 11 tons per hectare to almost 15 tons per hectare. But which is quite peculiar here is that the use of certified seed has remained very, very low. It's less than 0.05%. So as you can see here, we have sort of a contradiction. On one hand, we have this huge increase in production, in yield, in consumption, but at the same time, the use of certified seed has remained extremely low, less than 1%. Next one. So the potato seed is also called the potato planting material. Is a critical input for production, is the main input for reducing the yield gap. So for example, if we have a variety that has a potential of producing 50 tons per hectare, and here in Peru, we have a national average of around 15 tons, that difference between 15 and 50 is what is called the yield gap. So using good quality seed help us to reduce the yield gap. And also is the vehicle to disseminate new varieties. In this presentation, I'm focusing not on dissemination of new varieties or using existing biodiversity, but on the reduction of yield gap by using quality seed. So that is the focus of my presentation. One important feature of potato seed is that the crop is vegetatively propagated. So it's not true seed, it's tubers. We use tubers as seed. And there are several features. First is bulky. So we are using about 1 to 2 tons per hectare of seed tubers, which is an extremely high amount of tubers. It's very costly. It can go up to 30 to 40% of production costs. It's very perishable. You can store the seed tubers between 1 to 4 months, 5 months in some cases, and is extremely prone to degeneration. So all these features all these features make that the management of potato seed very special and important. Next one, please. Next, please. Okay, seed degeneration. Okay, so as I telling you, seed tubers, in the case of potato, are prone to degeneration. So degeneration is mainly the increase in pest incidence or severity associated with reduction in yield or quality over successive cycles of vegetative propagation. What I mean is that farmers usually keep a portion of the tubers that they harvest from one season and use those tubers as seed for the next season. This is what we call they are reusing their seed. But the problem is that pathogens and pests accumulate in the seed tubers. So we have several viruses, for example, PBX, PBY, PLRB. We have bacteria such as Ralstonia or Pectobacterium. We have fungi like Rhizoctonia in this case. We have nematodes like PCN, potato cyst nematode. We have several insect pests, for example, Andean weevil or tuber moth. So all these pests accumulate in the tuber from one season to another, and as a result, yield is reduced. Yield and quality are reduced. So degeneration is a huge issue in clonally propagated crops such as potato and other crops. For example, in cassava, in sweet potato, in yam, in banana is also a huge issue. Next one. So what SIP is proposing is to manage seed degeneration with what we call the integrated seed head strategy. Okay, this strategy combines 3 tactics. The first one is host resistance, using resistant varieties, and this is done through breeding and dissemination of new varieties. The second one is on-farm management, and this is done mainly by improving the capacity of farmers to manage their own seed. Okay, and the third one is the use of clean seed through certification, ideally. So these three tactics make what I just said, the integrated seed head strategy. Next one, please. So at the moment, what we see is that we are in what we called in this paper in Thomas Sharma et al. 2015, what is called the clean seed replacement paradigm. We see that in most developing countries, most of the government agencies, several NGOs, and in general research and development organizations are actually trying to manage seed generation by using clean seed exclusively. Okay, so this is the main. We see a lot of investment in this area. We see a lot of discussion, for example, around seed regulation. But this is just one component for managing seed generation. So in SIP, as I said before, what we are trying to do is to combine these three tactics. Use of clean seed, which is okay, but as you saw in the previous slide, sometimes it's actually very difficult for low-scale farmers to access certified seed, so they prefer to reuse their own seed. So they have these quality issues. So we are trying to combine these three tactics, and as a result, we have this integrated seed head strategy. We are designing new interventions in several countries, in several developing countries, to validate and to use this strategy. Next one. So here you can see the results. This is potato in several developing countries. And here you can see the coverage of seed from the formal seed system and from the informal seed system. This is to make my point about what I said before, this clean seed replacement paradigm. A lot of investment on this area, but these are the results. Extremely low numbers for certified seed from the formal seed system, and extremely high numbers for the informal seed, for the informal seed. In the case of Peru, we are talking about the first potato producer here in South America. You saw the data that I just provided, huge increases in yield and production and consumption, but the use of certified seed is extremely low. Okay, next one. So let me describe in a little bit more detail this integrated seed health strategy. The first tactic is using host resistance for managing seed degeneration. So here you can see the main agroecologies and stresses, both biotic and biotic stresses, abiotic stresses. And as you can see, PBY, PBX, PLRB, which are potato viruses, are common in all these areas, in subtropical lowlands, in temperate regions, tropical highlands, in dry Mediterranean weather climates. You have this, the presence, the incidence of these viruses, which cause degeneration. We have other pathogens that cause degeneration, for example, late blight, PCN, etc. But in general, I can say that the main cause of degeneration globally are viruses. So in the case of SIP, what we do is that the clones that we release around the world have resistance to these main biotic strains that cause degeneration. Next one. So here you can see, this is an example. These clones were sent to Guatemala early this year. We sent 16 advanced potato clones to this country. And as you can see at the right side, all of them are resistant or highly or extremely resistant to PBY, PBX, and in some cases to late blight. So this is as we say here among the plant pathologists, is the most elegant way of managing seed degeneration and improving seed quality. Is just by disseminating varieties that are resistant to the main biotic constraints. Next one, please. The second tactic that we are promoting in SIP is what we call on-farm seed management. In this case, I'm describing a very simple technique. It's called positive selection, or also select the best. Extremely simple technique, which is basically to work with the farmer, to teach the farmer that he should select tubers from the best plots and the best plants, and those tubers should be used as seed in the next growing season. So the first step is to select the best plot. In the case of the Andes here in Peru, farmers usually have more than one plot. This is a strategy to cope with weather variability. So they usually have several crops, and they know which of these plots are the best ones, the ones that, for example, has the best rotation period, the longest rotation period. So tubers should be selected always from the best plots. The next step is to go to the field around flowering and select the best plants. The best plants are those that are that have no symptoms of, for example, viruses or leaf blight or nematodes. Trying to select the best plants, the biggest plants with good stems, with no symptoms. Okay. Next one. The third one is to, at harvest, select the tubers from the best plants. So in this way, we are avoiding the diseased tubers, and we are trying to get the best quality planting material. And then to improve the physiological quality of this planting material, store the tubers under good conditions. So in this case, you are seeing a diffuse light storage. It's a very simple technology that helps farmer to maintain the physiological quality of the tubers. So just by using this very simple technique, we can increase yield by 30 to 40%. The issue with this technique is that it sometimes is in conflict with the recommendation from ministers of agriculture. The message that they give usually to farmers is that they should use certified seed. So working with extension agents from a governmental organization is really important to help them know that the generation can be managed not only by using clean seed from certified clean systems, but also by using resistant varieties, and especially by teaching the farmers how to maintain the quality of their own seed. Okay, next one, please. Then we have the third tactic, which is clean seed. Actually, I don't know if you know, but the certified seed systems were developed in Europe in the early 1900s, and these were designed because of degeneration. They wanted to manage degeneration, so they produced a system that allowed farmers to buy clean planting material, certified planting material. It was extremely successful in developed countries, but in developing countries that is not the case. You saw the table that I just presented. We have huge issues about using certified planting material. So in the case of certification, you see here the scheme that for producing clean certified seed in Peru. I would say this is the classic scheme for producing certified seed. We have the genetic class with in vitro plants and pre-basic mini tubers. Then we have 3 categories: basic, registered, and certified, produced by INEA, in this case, the NARS here in Peru. We have another category which is called authorized. Certified and authorized varieties are produced by seed producers, usually registered seed producers. And then we have a new class, which is called the non-certified class. I'm going to describe this in a little bit more detail later. But the certified class, the certified seed, and this non-certified class, these are the seeds that are being sold to the farmers. So this is a classic scheme for producing certified seed. Next one, please. And around the production of certified seed, we have this discussion about regulations. So, for example, in the case of Peru, we have an update. The seed law was updated in 2008. We have in 2012 new regulations for potato seed production. And in 2014 and 2015, SIP helped the the local officials, especially in INEA, to organize several workshops in Lima, Huancayo, Andahuaylas, Cajamarca, and Cusco to discuss these new regulations. And because we have two new categories, the non-certified class we declared, which comes from the quality declared planting material approach from FAO, and the traditional class. But we are still waiting for final approval. You know how this is. It takes a lot of time, a lot of effort. It's very time consuming. It's nearly 2 years that the new regulations for potato seed production are in place, but still needs to be approved. Next one, please. Next one, please. And in this tactic is also a lot of techniques. So, for example, in the case is very technical. This is not as in the case of on-farm seed management, for example, where you have simple techniques. In this case, you have more advanced and complex techniques. So, just for producing mini tubers, potato mini tubers, which is the pre-basic seed, you have several techniques. You have conventional production of mini tubers using soil, which produces 5 to 8 tubers per plant. You have a kind of hydroponics using sand, which is called sandponics. We can increase the yield to 8 to 10 tubers per plant. We have new techniques such as deep water for producing a clean seed of advanced clones. Then we have aeroponics, extremely complex technique, but also the most efficient one that can produce up to 100 tubers per plant. So around the production of clean seed, you have all the discussion about the best techniques for producing clean seed, for producing in vitro plants, for producing microtubers, for multiplication of basic seed in the field, etc. So it's a lot of technical issues around seed production. Next one. So the main message to finish my presentation is that at the moment, Peru is the largest potato producer in South America. You saw the data that I presented, huge increases in yield, production, consumption, but the use of certified seed is extremely low. The informal seed system in Peru provides most of the seed for potato production, but seed quality is usually quite low. That is why the yield is still around 15 tons per hectare, which is still low. The problem with this informal seed system is mainly seed degeneration, and this is the main cause of poor quality seed. And what SIP proposes now is an integrated seed head approach that combines host resistance, on-farm management, and certified seed. So all the discussion about regulations is just a small component on a tactic for managing seed degeneration, which is the production of certified seed. So I wanted to provide this bigger context of the issues around potato seed in Peru. So the final message, and this is more like a personal perspective, because there is also discussion within SIP about where to invest. But my personal perception is that investment should focus primarily on breeding and farmers' capacity building for on-farm seed management. I see that we have made huge efforts to improve the formal seed system, but the results after 34 years of work are very, very poor. So I would suggest to invest more on breeding and farmers' capacity building for managing for on-farm seed management, and to a lesser degree on producing certified seed. And that's it from me. Thank you very much.
Very good, Jorge. Thank you very much. I see quite a bit of questions already coming in through the chat channel. We'll collect them and we'll pitch them to the presenters at the end of their presentation. Thank you again, Jorge. You can go on audio and video mute. And I would like to ask Rose to unmute her audio and her video, so she's ready for the next part. So from Peru, we're going across the Atlantic. And I have the honor to introduce Rose Nankia, a conservation biologist who works for Biodiversity International as a program specialist in the Productive and Resilient Farms, Forest and Landscape Program, and is the Uganda National Manager for projects that promote conservation and use of crop genetic diversity to enhance productivity, resilience, and food security for smallholder farmers. She is also a fellow of the African Women in Agriculture Research and Development Award. Before joining biodiversity, she worked with the Environment Conservation Trust of Uganda, Uganda Wildlife Authority, and the Forestry Department of Uganda. She has experience of 18 years working with communities in conservation and sustainable use of natural resources, and 8 years of research experience working with farmers and other stakeholders in conservation and use of crop genetic diversity to enhance productivity, resilience, and food security. The floor is all yours for the next 20 minutes, dear Rose. Please go ahead. And you need to unmute, Rose. Your audio is muted. Rose, just a second, because I don't have any audio from you coming in. No, something went wrong, Rose. I've lost your audio. No.
Do you have it there?
Yeah, I have it, Rose. You're all online. Go ahead.
Okay. Good afternoon, everyone. I'm Rose Nansha, working with biodiversity, as you've heard. I have the pleasure to talk to you about community seed banking and how it enhances conservation and use of crop varietal diversity. Next, please, Charles. Next slide. We all know that local seed exchange networks that occur outside the formal breeding sector influence the diversity and evolution of plant genetic resources for food and agriculture. And there are factors that determine the use of seed by farmers, and these include availability, quantity, quality, as well as the price if farmers are to buy this seed. We've realized that community seed banks are effective in providing seed to farmers and also providing different varieties, as you are going to see in my presentation. Next, Charles. Generally, biodiversity takes this approach to achieve cooperation from the partners. We identify key implementation partners and contact them. And then after contacting them and selling our agenda to them and they've seen value in it, then we go ahead to develop memorandum of understanding to make clear the commitments, roles, and responsibilities of each party. Then we go down to the project site and do a situation analysis to understand the problems better and also get to know the target beneficiaries. And after identifying the beneficiary groups, we take on a participatory approach whereby the identified groups are all involved in the implementation of activities. We go ahead to understand and take into consideration the different perspectives of stakeholders or the beneficiary groups and try as much as possible to promote a win-win scenario. We keep in touch constantly with our partners during the implementation of the different interventions. Next, please. And in this regard, for instance, in Uganda, biodiversity partnered with the National Agriculture Research Organization, specifically the Plant Genetic Resources Center. And we carried out seed system studies using participatory diagnostics to understand various issues existing within the seed systems and how these influence diversity. We continue to have interaction with the farmers and other partners, and then explain the objectives of the research. And we also went ahead to recruit some of the field assistants from the target communities. And this approach created a lot of trust and confidence in us. And so the partners cooperated and supported the research program and the interventions that followed thereafter. Next, please. Next slide, Charles, please. And the objectives of the seed systems studies were to understand the seed and varieties distribution of the target crops, in this case, common bean. And we also had to understand the constraints to accessing this seed and the different varieties. We set out also to understand the seed selection practices and the linkage of seed systems to the crop diversity on farm. Next, please. Next slide, please. These are some of the findings from the seed system studies. We realized that farmers got most seed from the informal sources. And this is information from 2 study sites. We had Rubaya in southwestern Uganda and Kabohe in western Uganda. And in all these sites, the findings were almost similar. The majority of seed was being gotten from the informal seed systems. And we did this twice, the study in 2008 and then in 2013. And the results were almost the same. The other finding was that the farmers got seed from more than one source without quality control. And then there was a lot of exchange of seed between farmers on one village and maybe within even adjacent villages. We can go ahead to assume that some of the seed and the varieties that these farmers were accessing had been developed using materials from the CGIAR centers. Next slide, please. Charles, please. This graph is showing the quantities of seed that were gotten from the different sources in both 2013 and 2008. And you can see that still the same sources continue to provide most seed. For instance, the non-local markets, the very local markets, the neighbors, and also there was seed that was being provided by the farmers themselves through saving seed from one season to the next season. Next slide, please. This slide is showing how farmers were getting seed from different sources and goes ahead to show the number of farmers. You can see interaction, cross-section, implying that some farmers were getting seed from several sources. But you can also see that one farmer here was getting seed from a seed company, which is a formal seed source. Next, please. Next slide, please. It is the same trend even.
Rose, it takes 5 to 10 seconds of delay between Charles forwarding the slides, so he's coming.
Okay, please, he's already there. Thank you. This slide is showing still the same seed sources, and these are the results of 2013. They are not very different from the results we got in 2008. Still farmers getting seed from several sources and then exchanging seed within themselves and so on. Next slide, please, Charles. I would like to emphasize the key constraints that we found out that were limiting farmers from accessing seed and also from accessing different varieties. One constraint was about seed being very expensive to buy and transport, whereby they would go to markets and some of these markets were not within their villages, so they would need to pay money to transport those seeds, and this could limit the quantities of the seed they could access. The other constraint was about varieties not being available anymore. Even if they wanted to grow those varieties, they couldn't access the seed. And the other was about the seed quality. It was so poor. At times, seeds could not germinate. Other times, seed were carrying seed-borne diseases. And so that was also another constraint. There was this constraint about varieties getting tired when grown every season. And I think it referred to improved varieties that lose vigor with time. And then they also complained about a high turnover of varieties. For instance, they would go to the market looking for particular varieties, then they would get totally new varieties. And so that was also a constraint for them. Next slide, please. We realized through discussions with these farmers that community seed banks could be an initiative that would help solve these constraints. And so we went ahead together with them to implement community seed banking. And what are community seed banks? These are community-driven efforts through which farmers select, produce, improve, and at times market seeds of different varieties. They collect varieties together in one pool, and they ensure quality of this seed through setting quality standards for these seed banks and meeting these quality standards. Then they store a seed in the short term to serve individual farmers or several communities in different villages. They can revive rare and extinct varieties through working with the national gene banks. And then they promote and protect farmers' rights, as we are going to see in the coming slides. Next slide, please. These are the major functions of the seed banks. They avail seed at the right time on a loan basis, and this helps solve the issue of the expense such that farmers don't have to have money to access the seed they want. And then the quality control of the seed, whereby farmers themselves set the standards with the assistance from the technical people, and then they are trained to ensure that they meet these standards so as to have quality seed. These seed banks also avail diversity of varieties, and farmers are also crucial in collecting varieties and pulling them in these community seed banks. And also researchers can assist in bringing together varieties maybe from national gene banks and even from other countries where possible, so that farmers have diversity. They offer choices for farmers, and this is very important, especially at this time of climate change, because different varieties have different resilience levels. These seed banks bring seeds nearer to the people. They are located within the communities themselves, so they can easily be accessed by all the farmers that are interested. They go ahead to conserve varieties, even those that may not be so marketable or so tasty, or so even those varieties that do not have required traits at the moment are conserved in these seed banks. And they help link farmers to the national gene banks and the breeders for continued production of improved varieties, and also exchange of varieties at national and even international levels. They revive rare varieties and those that are extinct, as I already explained, and they improve social cohesion. They're working together. Because in managing these seed banks, people have to work together to ensure the quality, to monitor gardens, and so on. So the social cohesion is also improved. Community seed banks have also empowered women in several aspects, because women are even on the management committees of these seed banks, so they are in leadership positions. They are involved in producing seed, even for sale. So women empowerment is another big function that community seed banks play. And they increase farmer capacities, for instance, in seed production, in marketing, and so on. So they play a capacity building role as well. Next slide, please, Charles. And this is how they do their tasks. They secure diversity through collecting varieties from different areas, and they pull them together in this seed bank. It could be from national gene banks. It could be from other groups outside the country that they interact with. So that securing of diversity is very important. But they go ahead to characterize and get to understand all these varieties using the traditional knowledge they have, but also they are open to adding on more knowledge, even from the researchers and other partners that may have that knowledge. They produce seed, as we've already had, and then they store and they distribute at the start of the rainy season when the time is ripe for planting. So in that way, they secure diversity. Next slide, please, Charles. They empower farmers in good quality seed production and other necessary capacities. But also, they play a very important role in seed quality management, because only a good quality seed that meets the standards set by those seed banks is accepted in these seed banks. That the seed that does not meet those standards is rejected. And then they do participatory monitoring at farm level because they've been trained to monitor diseases on farm, so they are able to reject farms that could be diseased or where the farmers did not plant using proper agronomic practices. And that way they can control the quality. But they go ahead to treat seed while it is at the bank with organic materials using their traditional knowledge. And then they also have equipment for testing the moisture content, such that they are able to reject the seed that does not meet the moisture content as set out in their standards. They also carry out germination tests to ensure that the seed they have will germinate, to ensure that the seed they have is viable. Next slide, please. Community seed banks are also playing a very important role in promoting farmers' rights. They promote the saving, using, and exchanging of seed, whereby farmers can come and access seed, even of varieties that have been gotten from national gene banks, from other sources, even that could be outside the country. So that right is promoted, but also they promote the right of sharing traditional knowledge. For instance, if you got an opportunity to visit one of these seed banks, they would tell you how they treat their seed using organic materials. Then all the traditional knowledge they have about the different varieties, they share that knowledge. So that right is also promoted. There's equitable sharing of benefits. For instance, the benefit of the seed, the benefit of getting different varieties, all that they share. And then there's participation in decision making. For instance, when a season is starting, all the beneficiary farmers meet and understand what quantities are in the seed bank and how much they will be able to take out of that seed bank. Next slide, please. Here I would like to share an example of Kiziba Seed Bank that was established and opened in June 2010. And I would like to draw your attention specifically to the way the quantities of seed have been increasing and the number of beneficiaries. But I want to point here to the first season of 2016, I think. 2015, the first season. The season was so good, such that the farmers borrowed the seed, they were able to harvest, and then retain some of the seed for their next season, and return all the seed that had been borrowed to the seed bank. But the season that followed was very bad, that farmers didn't harvest much, and so they were not able to save seed for the following season. And so they flocked into the seed bank and took away all the seed to be able to plant in the first season of 2016. And this shows how seed banks can provide a fallback position in cases where the seasons are very bad. And in this era of climate change, we are starting to see that some seasons can really be terrible, and farmers can even fail to harvest anything. Next slide, please. In Kiziba Seed Bank, we've seen that it's progressing well. So far, 1,500 farmers have benefited, and these are from different villages. This might seem quite a small number, but what happens when a farmer borrows seed this season, that farmer may not come back the following season because that farmer is able to save seed continuously for the following seasons and may come later, maybe if there's a bad season. And so that way, we've been continuing to get new farmers, and those that benefited earlier on are not continuing to benefit so much. And in a season, this seed bank is distributing a ton of seed. We've realized increased productivity on farm because of the controlled quality. And we are starting to see that these seed banks are starting to go into seed production as a business, so as to see that their income is improved further, but also to ensure the sustainability of these seed banks. And this seed bank opened with 27 varieties of common bean, but now has 69 varieties of common bean. But it's worth noting that these varieties are popular at farmers to different extents, depending on the different attributes they have, like marketability, taste, cookability, and so on. And because of the capacity that was built in this seed bank, farmers are now able to impart the skills they acquired to other farmers. And by so doing, they've been able to facilitate another farmer group in Shema Town Council so that it establishes its own seed bank. Next slide, please. These are some of the benefits that the CGIAR centers are getting from these community seed banks, as well as the general research fraternity. Since seed banks are linked to the national gene banks, they are good channels for increasing access to the plant genetic resources for food and agriculture, so that these materials are available for research easily, for instance, for developing new varieties. And this can be within countries or even outside countries. They can be exchanged with other researchers in different countries. Seed banks can also be an easy channel of linking and working with farmers for any research intervention, because these farmer groups are already mobilized, they are out there, and because of the exposure they've had, they are willing to work with different partners. These farmer groups are also a source of data and information on seed systems, diversity issues, and any other related information. Next slide, please. These are some of the lessons we've learned in promoting community seed banks. We've realized that they may not work for all crops. For instance, they work best with self-pollinated crops. But also they may not work well with improved varieties, because with the seasons, the improved varieties may lose vigor, and as such, when they continue to plant them, they may not get good yields with time. The other lesson is that community seed banking is influenced by social, cultural, and economic factors for it to be successful. For instance, if there is a culture of working together in a particular community, that will enhance the success of community seed banking. And also, if there is that social culture, then there is also this exchange of varieties. That's very important for the success of community seed banking. We've realized that it's important to first understand the dynamics of the seed system to gauge whether community seed banking is the most appropriate intervention in that context. It may not be the most appropriate, depending on the problems that may be existing in different contexts. It's also important to think about and incorporate sustainability mechanisms in the process of establishing the seed banks, because as I've already told you, the different varieties are attractive to farmers to different extents. So they may not be interested in taking particular varieties. So there has to be a mechanism to ensure that these varieties continue to be multiplied out there so that they continue to evolve. It's also important to think through the research and developmental questions to be addressed through community seed banking. Next, please. Next slide. These are some of the challenges we've realized. Community seed banks are starting to go into seed production as a business, and this may threaten the existence of land races. Why? For instance, in Uganda, land races are not registered on the national list of varieties. And so if they are not registered, they are not allowed to trade in the land races because they are not on that register. And so if the land races are not on the national register and they are not allowed to be traded in, farmers may not be interested anymore in growing these land races. And as such, these land races will continue to disappear out there. And it is also a challenge in that the registration of land races is not a priority in many countries, including Uganda. And there are also sustainability issues whereby if such land races, for example, continue to be grown out there, they need to be grown periodically. And so that requires money. And if there is no way a seed bank is generating money, then it may be hard without a project for them to continue or growing these land races out there so that they continue evolving. There is also the challenge of the market favoring few varieties, such that farmers tend to be attracted more by those varieties that have market. Next slide, please. In conclusion, I would like to say that community seed banks have proven effective in improving seed security and enabling continued evolution and adaptation of different crop varieties in situ. They also provide choices and enhance resilience to climate change and other shocks, as well as promoting farmer rights. So despite the challenges I've pointed out and any others that may exist, it's important that we promote seed banks so that we improve access and use of crop diversity for food security and enhance the resilience of farmers. Next slide, please. These are some of the references that we can go to read more about community seed banking. Next slide, please. I want to acknowledge our partners who have funded us, the farmers, and all the governments and National Agricultural Research. All these are partners that we've been working with to promote community seed banking. Next slide, please. And I want to assure you that for as long as we use the right approach, farmers are ready to work with us so that we improve food security, livelihoods, and access to diversity. I thank you so much for your attention.
Excellent. Thanks, Rose, for your elaboration on seed banks and the importance of community seed banking. You can go on mute again, Rose, and the next speaker, Alejandro, you can unmute so you're ready for your presentation. Alejandro Argomedo is the program director of Asociación Andes, a Cusco-based non-governmental organization of indigenous people, working to protect and develop indigenous peoples' biocultural heritage in the Potato Park and beyond. He is the founder and coordinator of the International Indigenous Peoples Biocultural Climate Change Assessment Initiative, IPCCA. Alejandro is also the founding member of the Indigenous People Biodiversity Network, IPBN, and the Call of the Earth Group. Both are global coalitions of indigenous people working together towards the shared goals of protecting and nurturing biodiversity and protecting their biocultural innovations and intellectual property. He is the coordinator of the Mountain Communities Network and the former executive director of the Cultural Survival Canada and Indigenous Knowledge Program. Please go ahead, Alejandro. The next 20 minutes are yours.
Thank you very much. Good morning, everyone, and I thank you for the opportunity. Next, please. As I have been introduced, I'm director of programs of Asociación Andes in Cusco. You see there the picture of Machu Picchu. I'm not, unfortunately, Machu Picchu, but I'm very close. So my organization has been working doing independent research, focusing and supporting indigenous peoples through independent analysis and resilience building of their food and agricultural systems. And for this, we have used a biocultural approach and which has allowed us to network at a national and international level. And through it, we have fostered new forms of cooperation and alliance building. So quite a bit of our work is on networking. The focus of my presentation is going to be first a very short introduction of the biocultural heritage aspects of our work, under which farming rights is being implemented. Then I will go into introducing the work in the potato park and the background of the potato park International Potato Center Agreement on repatriation, its impacts, and we'll go into discussing the lessons that we have learned and the conclusions of this social learning experience. Next. Peru, as you know, is a center of origin of very important food crops. We have here that we have more than 3,000 varieties of land rices in Peru. Cusco, the Cusco region has approximately 2,000. Also, Peru is next, please. Next. I think hello.
Yeah, so, it takes 10 seconds or something before the slide shows up, so no worries.
Like I'm in the previous one. The previous slide, please. Yeah. So Peru has been, of course, as I said, the center of origin of many crops, and so also is agriculture has evolved here for more than 1,000 years, and have evolved independently from the rest of the world. So our heritage in terms of knowledge, agricultural technology, and the role of culture in building resilience of this system is very old, so that we use that approach to build better and or adaptive responses to the current challenge that we have in terms of climate change, environmental change, sociopolitical and economical problems, and particularly to empower our peoples through the use of their identity and knowledge systems. So Peru is living also right now a very complex times where economical development is based on extractive industry, particularly mining, and where agriculture, particularly related to a small farming, is being impacted in terms of water use, access to resources, etc. So agriculture is a key for resisting this onslaught against the erosion of rights. We have signed free trade agreements, and Peru is one of the implementers of UPOP, the UPOP Treaty, which is eroding the local, or potentially will erode the local seed system. And we see our rights and the future of food in the country is strongly linked to the maintenance of our identity and our culture. So in this, the implementation of farming rights has been approached from a more integral view, where development, conservation, and the implementation of environmental treaties come together. So farmer rights, as established in the treaty, in Article 9, it's seen in conjunction with Article 8A of the CBD and provisions of the Nagoya Protocol. And therefore, we link this to national legislation and international human rights approaches, so that we can have a more stronger approach by which indigenous peoples can have rights over the traditional knowledge, the genetic resources, and self-governance of the agricultural and food systems. In this, our approach has been to develop a working framework that we call it biocultural heritage or indigenous biocultural heritage, under which we treat indigenous people's knowledge, practices, the biological resources, landscapes, and the economical systems and to which under which they work. So for this, this has helped us to look this the issue of farmer rights in a more localized fashion, and see local problems, local issues associated to food security and particularly climate change as our central focus. Next, please. The Potato Park is an initiative that 6 Quechua communities in the Pisac Valley, in the Sacred Valley of the Incas, started in the year 2000. This association of communities has a governance which is collective and based on customary laws. So the communities has a population of around 5,000 people, and an area of close to 10,000 hectares. Currently, the Potato Park is an area that has the highest diversity of potatoes, or native potatoes of land races in the world. We have 4 wild crop relatives in the area, and was established with the objective of improving the well-being and food security of the 6 communities. And from the beginning, the approach was to base the activities on traditional knowledge, but using principles and values of Quechua culture, to particularly of reciprocity, to link to external actors, and so that we could build resilience together. Next, please. The Potato Park has various activities. We have Andes and the Potato Park has been collaborating from the beginning. So we've been very active in, on policy, and the policy side. The Potato Park collection has been included in the multilateral system of the international treaty. The Potato Park has been one of the first communities that made a deposit of its collection in the Svalbard seed vault in Norway. And it's also a declared no patent and no GMO area, and has been very successful in working closely with local authorities and successfully implementing GMO, one of the first ones in Peru, a GMO-free region in the country. We have an approach that can be defined as a integrated landscape approach. Though we concentrate the work in the maintenance of plant genetic resources and the sustainable use of it, conservation, sustainable use, with a well-organized knowledge management system. The central focus still food, land, water, and to keep the access to those resources. There's various activities in the park, but the conservation of potatoes is one very important one. We have wild crop relatives work, gene reset that's being implemented. Focus on water use, agroecology-based production system, and very active work on participatory plant breeding and participatory variety selection. Next, please. One of the key highlights of this 15 years or so of work in the Potato Park was the Potato Park SIPA repatriation agreement, which was initiated around the year 2002 when we approached the International Potato Center for the repatriation of the potatoes that were collected in this area around the 70s. It took us 2 years to negotiate this agreement, which was well received by the center. Nonetheless, the legal and content issue were debated, and the first agreement was signed in 2004. And then we have, so to speak, re-signed it in 2010 and 2015. So this is the third time that the agreement has been validated again. The agreement promotes the cultivation or the use and maintenance of the maximum diversity of potatoes. And through this agreement, as I mentioned, the Potato Park has become one of the places that has the highest diversity in situ of potatoes in the world. And to continue the custody of these resources by the communities using the traditional knowledge and without the application of any type of intellectual property rights. And also the agreement, one of the objectives is to promote collaborative studies and research between the complementarity of ex situ and in situ strategies for the conservation of potato diversity, which gave the park a key role in the management of their own resources. And also promotes the cooperation of the parties with third parties and to enhance the protection of biological resources, and also promote the respect for the rights of indigenous peoples and local communities. In keeping this agreement, the parties agree that to be mindful that the traditional principles associated to customary laws and practice should be respected above all. you see that this agreement had the key, all the elements of the farmer right provisions of the treaty, and also took other provisions of the CBD work on traditional knowledge, and also other human rights aspects associated to biological resources. The other aspect, the treaty, the scope of it, and the nature of the treaty strongly focused on social learning. Are very important to mention here, and also this link between national and international law, the responsibilities that the parties have, CIP, Potato Park, and Asociación Andes, the normative aspects, the link to the treaty and the CBD, particularly the work on bioculture protocols associated to the Nagoya Protocol, confidentiality issues, knowledge and information management, benefit sharing, the duration and conflict resolution. Next, please. So far, through the treaty, the Potato Park has received 4,010 varieties of potatoes. We are preparing a new batch to arrive during the course of the year. Also, it has served as a platform to develop similar agreements. At this moment, the Potato Park is in negotiation with a Vavilov Center in Russia for the repatriation of a collection that was collected by the Yusef Czech in the year 1927, I believe. Also, we have implemented a very active and dynamic collaborative research focused on climate change, where we are measuring how crops are moving up in the mountain, integrated pest management, participatory plant breeding, participatory GIS mapping, wild crop relative work, and methods, tools, and processes for in situ management. We also have some collaboration on seed policy. We have co-organized workshop to look at the implementation of Article 11 of the seed law, which looks particularly at heritage seeds that we believe could be an avenue to protect all the diversity of seeds that we have in Peru. Next, please. Now I'm gonna go into looking the lessons that we have learned through this agreement, and with a view of framing it under the social learning aspects of this experience. And the first is in terms of engagement, and we see that the agreement have has been very conducive to have an active engagement of community members. When the potato repatriated batch came, elders, children, and particularly women came to see these lost varieties that are very associated to cultural practices. But also, Andes has worked from the beginning in the design and implementation of the agreement. So there has been a highly participatory process, and which is now being also maintained in the design of research activities. CIP has gained access to knowledge, those particularly associated to climate change and management issues in the potato park. And also, this has been, in the same time, Andes and the communities have learned a lot through the agreement. Once the research studies are completed, we have a validation of data. That means that we have to compare and validate knowledge systems. So this has served to better understand where we come from, but also see with a more in a more integrated way the problems that we have and create solutions. This has been crucial to build trust and has led to having high awareness of, particularly for the SEEP scientists, of the value and of traditional knowledge. The use of research methodologies and communication systems associated to the management of traditional varieties of potato, which is a key element of the work of the Potato Park and Andes, has been also key as it creates this bridge between how you manage taxonomies based on sciences and taxonomies based on traditional knowledge. Next, please.
Alejandra, sorry to intervene. We have 2 minutes left to wrap up, please.
Yeah. Okay. In terms of collective iterative learning, we have co-creating knowledge together. This you can see it in many aspects of our work. Also, the collaboration between SEEP, Andes, and the Potato Park communities in various research. The agreement is quite flexible, so allow us to include new themes always, so that these type of agreements are always working documents. And there's collective learning. Next, please. Another lesson learned is in capacity development. Capacity at the beginning is crucial if you want to work, have a more equal relationship between farmers and scientists. And this is a two-way process. It's not just scientists providing information and knowledge to communities, but also communities teaching scientists about many aspects of the work that we do. Regoverning the commons and food systems has been also one output of this. Farmers now go to other communities to provide information. Next, please. And scientists, in terms of challenging institutions, these type of agreements must challenge institutions, not just scientific institutions, but also government offices and other parties, so that we can influence the shift in values of private and public institutions, and have the voices of farmers more stronger at the national and international level. Next, please. As a conclusion, I think agreements that based on the local views can create this stronger participation, not just in the research process, but how the result of that research can be applied to solve local problems. The recognition that farmers, especially women, have in terms of conservation, the leading role that farmers can play in terms of policy development, and of course, this is not only all good, but there's still more work to do in terms of trust there's low sharing of information, all the research activities that we have, and the fact that CIP has no institutional funding for this agreement of orders of this kind. So that, of course, has a limited spread of the effects of this agreement in other CIP offices. Thank you.
Very good. Thank you, Alejandro. We have questions coming in, and I do encourage the public to keep the questions going. Meanwhile, Jeremiah, I see you coming online. Jeremiah, or Jeremy Barbet, is working for GODAN, the Global Open Data Initiative for Agriculture and Nutrition. Jeremy is a Juris Doctor candidate at the University of Ottawa. He has worked for 2 years with Professor Isabel Peterson in the Digital Culture and Media Lab, where he established a digital archive to track how rhetoric drives innovation. Jeremy was previously the president of PSAC, Local 55, advocating for teaching assistants, research assistants, and sessional faculty at the University of Ontario's Institute of Technology. His interests include in social justice, intellectual property law, and entrepreneurship. Jeremy, the next 20 minutes are yours. Go ahead.
Hello, can you see me? I don't see myself. Yes. Just checking that
I can hear it, so you're fine.
Perfect. Thank you so much for having me. I'm here working with the Open African Innovation Research Network in partnership with GODAN. The Open African Research Network is a network of researchers across Africa and Canada. And we have 2 broad research questions. First, how can open collaborative innovation help businesses scale up and seize new opportunities of a global knowledge economy? And second, which intellectual property policies will ensure the social and economic benefits of innovation are shared inclusively? And one of the things that we've been working on is legal frameworks for data, and specifically open data, with the Global Open Data for Agriculture and Nutrition Network. They're a network of over 588 partners, national governments, non-governmental organizations, international private sector organizations that are committed to ensuring open data around the world, and specifically in agriculture. You can move to the next slide, please. So agricultural data is a vital resource for ensuring food security, and I'm going to talk about data quite broadly here. Data in this context involves any type of data within the food production chain, but specifically can involve things like data on best practices, scientific research, weather and markets, geological, satellite data, soil data, weather and market data, crop yield data, pest data. All of these are types of data that can be opened for and subject to an ability to access them open. And so I'm going to go to the next slide, please. This is one of the definitions, primary definition of open data. It's data that can be freely used, reused, redistributed by anyone. And that usually occurs through the internet. And the value of this is the ability for anyone to use this for whatever purpose that they want. So this can mean that farmers can benefit from the outputs of data, and but also many other people can as well throughout society. And GODAN really sees this as a way to promote food security around the world. You can go to the next slide, please. So I've already gone over some of the sources of open data, but I just want to reiterate that any one of these types of data can be open. And so, yes, you can go to the next slide. One of the things that we've been working on is a focus on the ownership rights associated with data. This is a major factor in opening and providing access to data. what we found, and I encourage you to look this up. This is a publication that is available on GODAN's webpage, is this paper on the ownership of open data. And one of the things that we found in writing this paper is that stakeholders that are the most vulnerable are smallholder farmers. They have some of the least legal protections. And so I'll talk about that in a second. You can go to the next slide. These are some of the ownership mechanisms that are available to control how data is used and accessed. Copyright, for example, is one of the most prevalent. It deals with the access to original expressions. And in this context, when we talk about data, data can mean both the individual pieces of data. So, for example, the yield of a crop from a farmer's field, but it can also refer to databases. And in copyright, there is no ownership mechanism over individual pieces of data. They're considered to be pieces of information. But there are mechanisms to own databases. And that's not just in copyright. In the European Union and in Mexico, there are also unique database rights. And these rights allow people who have created databases or own databases to control who accesses and uses those databases. Other mechanisms for ownership include trade secrets and confidential information. So this would prevent a company that collects data would be able to prevent the access or use of that data simply by not revealing it or using some technological measure to prevent that. Another mechanism is personal privacy. So especially in Canada, United States, Europe, there are laws that require companies and other people who want to collect data to get consent. And a lot of the time, when these relationships are managed through contracts. You can go to the next slide. So these laws, these intellectual property laws, view three different types of stakeholders within the data infrastructure, the ecosystem of data. First are contributors. These are the people that originate data, that have the source of data. Often these are farmers. They might provide access to their fields. They might collect the data themselves, or they might, in some other way, be part of this ecosystem. For example, when drones or satellites take pictures of their fields, they may not have control over that directly, but they're still directly contributing to the creation of this data. Then we have collectors, and these are the people who are collecting data. They're often governments, they could be private sector corporations, NGOs, and they're the ones that are collecting, compiling data. And then finally, we have consumers. Consumers are the people who might want to use the products that are created from the data. Often they also can be farmers that are perhaps using weather data to understand when to plant crops or make other decisions. And each of these three stakeholders have specific roles and rights and responsibilities assigned to them through intellectual property. You can go to the next slide. What we are proposing is a governance structure where all participants share responsibility for and engage equitably in the production of data. And the reason why this is important is because intellectual property rights focus on those collectors of data. They're the ones who ultimately own the data and have control over it. They are able to control access to the data from consumers, and they're responsible for collecting the data from contributors. And so this creates several challenges and risks potentially for contributors. And for example, if a corporation has a global view of a large number of field data regarding field yield or say the water levels on fields across, say, a country, that can change market speculations. Like they can use that to set prices. And on the other hand, you could have governments that make decisions and set regulations based on this information. And so there are also a number of benefits that can be derived from this data. They can be used to create new products that can be sold for value, and oftentimes contributors, farmers, they may have given this data over, but they're not going to see the benefits of that data. And so this is where we see a data commons being very important, where all participants are brought in and share responsibility for engage equitably in the production of data. So you can go to the next slide. These are some of the things that we've found that contributors need. First, they need engagement. Contributing farmers are very interested in how they're in their data, how it's being used, how it's being collected, what it's being used for. And one of the first things that and this is really the overarching thing because it controls and affects the other three, is some kind of conversation with farmers about how their data is being used. So this leads directly to the next one, which is privacy and control. Farmers need assurances of privacy. These are legal requirements in many countries, as well as being expectations from farmers. I've already mentioned the potential benefits that can come from data, and benefit sharing is one important thing for farmers. And finally, they need access to their data, both their individual data in precision agriculture to make decisions that affect their farms, but also more broadly, the benefits that flow may come back to farmers through access to data. For example, going back to the weather, farmers that have access to weather data are clearly going to benefit from that data. Now, they may not be providing that data directly, or they may be offering some sort of weather station on their farm, and then they're directly involved in that chain. But we see the data commons. Sorry, you can go to the next slide. We see this data commons, which we're proposing as a way to address the needs of contributors. So although contributors do not own their own data, we see that their needs can be met with licenses that open access, that ensure open access. And in our research, we've taken a look at 3 different case studies to try to understand how the data collection is occurring and how different business methods and legal sophistication, different levels of legal sophistication, methods and access to data control the use. So you can go to the next slide. First, we took a look at John Deere. So John Deere is a very sophisticated actor. They are very involved with precision agriculture, and they have quite sophisticated contracts. That lay out privacy and control of data. They're very clear right at the very beginning of their agreement with farmers that participate that they own their own data, despite that not being necessarily true. And they also include a clause at the very bottom of their contract that says that despite this ownership, they own the aggregated use of data, and participants are giving them permission to engage in commercial uses. And these commercial uses include marketing back to the farmer, as well as developing new products. So one of the lessons that we can learn from John Deere here is the need, first of all, for sophisticated contracts that are very clear about privacy and control, but at the same time managing the need for benefit sharing. I've also talked with folks at PlantWise, and PlantWise is an NGO that it works with governments around the world to help farmers by providing them with plant clinics. So farmers can bring their crops into these plant clinics that are staffed by government extension workers, and the extension workers can diagnose the plants, and in doing so, they collect quite a bit of data about the plants that's quite useful. Now, this is pest data, and there are a number of security issues with the data. PlantWise is very clear that the data is owned by individual governments, and yet they're still working to try to open their data up in some ways to help derive some sort of benefit from the data. And one of the insights that we've gained from this is an understanding that stakeholders need to see the value of the shared data. They need to understand that when data is open, that there's going to be some sort of value back to them. And this applies to all of the stakeholders. And finally, I want to quickly talk about an exciting social enterprise called Abalobi. They are based in South Africa, and they work with the smallholder fisher community off the coast. And what they've developed are a suite of apps that offer ways for fishers to track their catches, to manage their businesses, and also to sell their catches on an open market. And when they began their design process, they found that very quickly that it was necessary for them to build ownership into the design of their apps. And this was because the fisher folk had very low trust of any sort of data collection mechanism. So they have very clear statements as you first sign in and become a member of their program and download their app that says you own your data and we won't access it for any reason. If you want, we can share this data with the South African fishing regulator, but that's up to you. They also have a very unique approach to show the value of open data to these fishers through their market. And their online market allows the fisher folk to sell their fish around the world. And when they do, they create these fair trade stories that fisher folk are able to add some of the data that's collected naturally through the app, and the fisher folk agree to open that data and release it so that people can understand where their fish is sourced from. And in doing so over time, they're able to collect a database of open data that is available to help understand where fish are caught. So all of these examples really show the need for both a relationship not only with consumers but also with farmers. And so I want to now talk a bit about the relationship with consumers. If you can go to the next slide, please. So these are two governance mechanisms that are commonly used to license data and specifically license copyright in data. The first here is the Creative Commons. And I noticed in one of our participants is Syngenta, and they offer open data bases that are licensed in Creative Commons. Creative Commons offers a range of licenses, and they have a number of innovative features that have helped increase the adoption of Creative Commons as a way to publish. This includes a 3-layer design that includes both the machine layer as well as the human layer and the legal layer. So the human layer makes these contracts very easy for people to understand, and you can go through a wizard that you say, these are the needs that I have, and it gives you a suggestion for a license. The Open Knowledge Foundation says, just to go back quickly to the Creative Commons, one of the features, if you apply the Creative Commons license, is that you're not only licensing the data itself, the database, but any copyright that may possibly exist in data, which could be, say, an image. The Open Knowledge Foundation is a very similar license, but it only specifically licenses the database, the compilation of data. So we already have really good ways to manage the relationship between the collector and the consumer, and we can build this into the data commons that integrates a relationship between all three parties. So that's what we are proposing. You can go to the next slide. What we're proposing is a set of licenses that can help collectors manage their relationships with contributors and with consumers. And sorry, you can go to the next slide again. This is what it looks like. We have collectors that are, first of all, licensing collection and then licensing distribution. So if we can match these two licenses up, then we can have an effect across all three stakeholders that helps, first of all, collectors collect data a bit easier, but also helps promote and ensure that there are open means for distribution. So if you can go to the next slide very quickly, I'll just go over some of the characteristics of the license. First of all, something like this, following a Creative Commons model, would be created through engagement. It would balance stakeholders' needs, so the need for privacy with the need for openness. It would give collectors modular options. So maybe a truly open data model is not the best for a particular collector's business model, and that's fine. But maybe there are other ways to share the data. And then finally, it would follow some of Creative Commons best practices to maximize use. So finally, to the last slide, or second to last slide, we see social certification marks as a way to grow traction for our proposal, looking to fair trade and the Forest Stewardship Council, Fair Trade Music, as possible ways to encourage participation and ensure benefit sharing. So if you see this label that says this is an open data commons, then you might be more likely to participate with either sharing data or using data. So quickly before my time runs out, I just want to go to the last slide and thank our funders, and encourage you, if you would like to read more, to go to our website where openair.org.za, or actually we now have a new domain, openair.africa, where you can find our working paper on this topic. And I just want to thank also our funders, the Social Science Research Council and IDRC Canada. Thank you.
Very good, Jeremy. And don't go away, because while I have you online and unmuted, I have the first question for you. We're going into the Q&A session now. I'll pitch some of the different questions that we had from the audience to each of the presenters. May I remind the presenters, if somebody wants to add on one of the comments from another presenter, please unmute and join in. So Jeremy, while I have you unmuted, a long-term sticky point. Are you ready?
Sure. Yes.
Open data and research. A long-term sticky point where a lot of research and its related data is published in journals which is closed and payable, and very often very expensive access only. And those journals seem to have a monopoly on acknowledged and recognized research publishing. So what, according to you, is the future to ensure that agriculture research is accessible to those, and its data, of course, is accessible to those who can translate this data, this research for practical use by farmers? Go ahead.
Thank you. So open data is one part of open access, which is a much broader topic or conversation of how can we make sure that knowledge is accessible to everyone. And within that, open scientific publishing or open scientific research is a very important piece of that puzzle. Now, I really think that you're right in identifying that this is quite a difficult scenario for many researchers that want to have impact because many journals are closed. But I think it's incumbent on us as researchers and scientists to insist on open access when we publish. And part of this involves building funding mechanisms into our grants when we write. So often open access journals will receive their funding through the researcher having to pay to put their paper on the journal, but it can also involve simply insisting that journals and their editorial boards seriously consider open access as a way to publish. And when really, if you look at the publishing industry, it's the researchers and scientists who are driving that industry, and I think it's incumbent on us to take lead in that matter.
Okay, thanks, Jeremy. If you could go on mute for a moment. The next question is for Jorge, and it's somewhere related to the transition going from research to farmers. Jorge, I have a question from John, who says, Jorge, what are you doing to make your innovations and your research and your experiences available to farmers in remote communities? And can you give some practical examples of success stories? Go ahead, Jorge.
All these innovations, all these technologies are disseminated mainly through projects. So here in SIP and in other CGIAR centers, we write proposals and we get money from donors basically to implement our activities. I have a couple of examples. For example, one in Ecuador, where we work with the Ministry of Agriculture to implement an improved seed system, I would say. But what is important in this example is that at the beginning of this collaboration, we propose to work basically with two approaches at the same time. One is produce clean seed, a certified clean seed, and the other one was to work mostly with farmer seed, with farmer safe seed, and with positive selection, for example, to improve the quality of this seed. At the end, what the government wanted was to produce certified seed. So this is just an example that shows you that usually governments prefer this more technologically driven approach, which is producing certified seed rather than improving farmers' safe seed. We have also several examples in other countries, especially in Africa. For example, we have a large program that works improving the quality of potato seed in farmers' fields. And in that case, we have nice examples of integration of these tactics. So we disseminate new varieties with resistant to viruses, for example, and at the same time, we teach the farmers how to improve the quality of their own seed. And the idea is that they will buy seed every 3, 4, 5 years, depending on their conditions. In lowlands, for example, seed degenerates faster than in highlands. So depending on that, and also on the level of resistance of the variety, farmers ideally should have access to certified seed.
Mm-hmm. But and related to that, Jorge, while I have you on the line, from Kim says, has cost efficiency been accounted for in the clean seed system? She means that while cleaner and superior seeds are produced by companies, their prices typically would be higher, and thus less accessible for poor farmers and small-scale farmers. Do you have both private or public/community seed banks companies in Peru, and how is that working, that dynamic in terms of cost efficiency?
I would say that is one of the big issues of producing certified seed in developing countries. For example, in Peru, most of the certified seed is produced by governmental organizations. So the efficiency of these organizations is relatively low, so the cost of production is high, and that is why certified seed is expensive. We see that in developed countries, most of the certified seed, all of the certified seed is produced by private companies. So the efficiency of those companies is higher, and the production cost, the price at the end of the certified seed is more competitive. So I would say this is a big issue in our countries, in developing countries, that the certified seed production is dominated by governmental organizations that are not that effective for producing seed in a competitive manner.
Yes, and your recommendation would be?
Well, we are trying to create these public-private partnerships to work with private companies. It works with, for example, these vertically integrated value chains where you have, for example, a big processor that have contracts with farmers. So in these closed systems, you have that the private company have their own seed multipliers. But in low scale farmers, the situation is much more difficult. In that situation, I would prefer the most soft approach of just improving the quality of native varieties that have resistance to these degeneration pathogens.
Okay, very good, Jorge. Thanks. I have a next question to Rose. Rose, if you could please unmute so I can see you're on the line. Rose, I have a question from Annalie, who congratulates you on the nice presentation, and she says, could we please have more info on the business aspect, the business arm of community seed banks? You were mentioning that some of these community seed banks would be commercializing their product. More details in terms of who would be selling to who and at what price. And in the end, can everyone in the community still afford it and have access to the seeds of the community seed bank? Go ahead, Rose.
Thank you so much. Yes, the business aspect is to do with farmers starting to produce a class of seed that is new in Uganda, not yet even approved. It's called quality declared seed. And this is seed that can be produced by farmer groups. So it involves going to breeders to buy the pre-basic seed such that they bring it to their farms and they multiply it, and then they get certification from the Ministry of Agriculture and they sell. Who are the buyers? The buyers are not necessarily farmers from that community because now they are producers of that seed. The buyers can be like non-government organizations that have projects in particular areas that are promoting such crops. They can also be government programs that are also giving seed subsidies. So it's not necessarily the farmers in the area where the seed bank is that are being targeted for buying the seed. It's not cheap seed. It's almost at the market price because the incur costs of buying the pre-basic seed, then ensuring that they put inputs like fertilizers, pesticides, to ensure that it's really of the quality that the ministry can certify. And so the cost is high. And many farmers where the seed bank is located cannot afford that.
Mm-hmm. But then probably the question comes back to, okay, we're talking community seed banks. So it would be the community that is contributing to the seed banks. What would be your recommendation to ensure that there is a differentiation between the commercial use by, for instance, companies and going back to the producer, to the farmers, that there's a differentiation in pricing? Is there a protection of access by the farmers to the community seed banks that they have actually provided input for? How do we protect the rights of farmers in that?
Okay, the differentiation comes in a way that these seeds get different labels. The label for certified seed is different from the label of seed declared, whose quality is declared, termed as quality declared seed. And so the fact that they have different labels, then their prices differ. Certified, of course, is at the highest level. And then the farmer's seed, which is declared, is in between there. But how can we protect farmers? I think one way to protect the farmers is to attach a story to this seed. More so, if farmers can still produce that quality declared seed using organic means, that would be an easier story to sell out there, and perhaps it would go to some niche market. This is just starting, so we are still experimenting on it and learning lessons here and there.
Yeah, and I would like to piggyback with another question that came in from Kim that is related to this. Is could you give us examples or share a bit of your experience how these community seed banks are incorporated within a community? She means how are they organized and who organizes them? Who takes the lead? Would it be the local chief? Are these government authorities? Are these farmers groups? Are they organized in cooperatives? Who would be in charge of a seed bank? Some of your experiences and some of your recommendations. Go ahead.
Okay, where we've actually initiated these seed banks in the communities where they are, but initiating them we hand over, because while establishing the building, for example, the community contributes. At times the leadership, the local leadership also contributes something like land, and the farmers can contribute materials, and we can also contribute, make some financial contribution. So the ownership of the seed bank is in the hands of a community group in a particular area. And so that community group selects a management committee that is responsible for managing that seed bank. But of late, we've realized that to ensure sustainability of these seed banks, they may not have to only do seed production per se. So we are looking into other avenues like doing collective marketing of the produce, for instance, of yield, of grain, because when they access the good quality seed, the productivity or the yields increase, and so they have to market this extra yield. So they are starting to organize themselves into cooperatives so that they do collective marketing of this yield that is increasing as a result of accessing good quality seeds. As for now, these community seed banks are only linked to the National Gene Bank for technical support, and the National Gene Bank is within the National Research Organization. So that's the linkage we have. But when they register, because we've been encouraging them to first register as community-based organizations, and as they grow, they can register as NGOs. And right now, they are going into registering as cooperatives. And there's a cooperative movement in Uganda that is responsible for the running of cooperatives. So they get a certificate as a cooperative, and they are under that cooperative movement.
And in that process, you or biodiversity is providing guidance in that governance, correct?
Yes, we keep giving them technical support together with the National Research Organization. And so we are always there, and we monitor to see whether they are on the track, the way they agreed to implement things. So we keep monitoring the benchmarks to see whether they are moving ahead or they have issues that we can help work together to solve. So we are always there. And right now we are getting many people who want to visit them and learn from them. So we are coordinating all this together with them.
Okay, very good, Rose. Thank you very much. Alejandro, the next question is for you. If you can please unmute. And it's a combination of a number of questions which came forward in both the presentation from Jorge and Rose, as well as yourself. Alejandro, you said that the potato park was not only a non-GMO area, but also a non-patent area. Now, what, in your experience in declaring it a non-patent area, and your struggle probably to reach to that point, what would be your recommendations? How farmer seed banks, maybe in other areas of the world, can be protected against biopiracy? That means against expropriation by commercial corporation, by patenting or putting under UOV, and you mentioned this, and the plant breeders' rights. Which is an instrument of private commercial property. People mention, Richard added, the challenges with UPOV and PBRs and patents is that it's the same for all smallholder farmers. These aim to protect more the private companies' knowledge while taking away the indigenous knowledge systems that farmers have used for generations and knowledge. Your recommendations, please, Alejandro.
Yeah, in the case of the potato park, I have to underline this. We don't call it seed banks because banks by default, have this structure of accumulation, and we have very bad experience with, the framework or the paradigm of banking. But having said that, the Potato Park has the infrastructure and the system for managing all its diversity of potato, more than 1,400 varieties that we kept. Now, this is done under customary norms that are protected by the Peruvian Constitution and also by international legal and normative framework, including the Declaration on the Rights of Indigenous Peoples, the ILO 169 treaty, and other treaties related to the environment. So the management or the governance of the seed system is primarily done using this combination of customary laws with human rights or indigenous people's rights law. The associated knowledge management also focuses strongly on using traditional knowledge, because all the science that CIP may bring or other scientists may bring, it's understandable at a community level. From biology to genetics to other areas, that's the realm of scientists. But we need a system that actually manages the knowledge that exists locally and then that can be used to solve local programs, and where the experts are farmers themselves. So if we develop, like we have done in the Potato Park, a knowledge management system and governance systems of seed and food and agriculture, then there is a strong possibility to defend the rights, be it using human rights law or using existing legislation related to participation of local and indigenous peoples and development issues. We in the country have a law of consultation, a law of participation that must be upheld if there is any type of agreement. We know that the intellectual property system has its own framework. We cannot think of going over it, but nonetheless, as long as the systems that exist and are managed locally are done under customary laws, I think we have better chance to protecting the intellectual property and the management system that communities have developed. We must remember that diversity exists in areas where these indigenous people have domesticated these crops. We have 10,000 years of agriculture. So that means 10,000 years of managing seeds, 10,000 years of exchanging and in the process developing rules and norms that apply to accessing, distributing, and creating benefits. Allow me to say this: the Incas created a very rich and sophisticated state, and they did so without markets and without money, with a strong focus on food. And food has been always our main concern and our main preoccupation here. Under that may come issues that are related to monetary benefits, and markets. The system here has worked and it's working fine. 99% of the potato seeds come from the so-called informal sector, so we are doing fine.
Okay.
Thank you.
Very good. Thanks, Alejandro. We're coming to the end. Last question is for Jeremy. And Jeremy, I have another sticky question for you. Are you ready? You can unmute Jeremy. It is a question coming in from Selim. Are you there, Jeremy?
Hello, can you hear me?
Yep, I have you. Jeremy, open data and usable data.
Yes.
Selim says scientific data is often presented in a complex way that might not be directly understandable to farmers, or let's call them ordinary citizens. Can you provide your experience in transforming open data to information accessible, understandable, and usable for farmers? Where is the link, and what of your work is related to that?
I think this is very important, first of all, because open data does present an opportunity for scientists to communicate with farmers around the world. So farmers in South America or Africa can benefit from data that has been generated by scientists, say, in Europe. And yet this point is very important as well. The farmers themselves may not be able to directly benefit from that, but that doesn't mean that there aren't benefits to be gained. And where I see a lot of those benefits occurring is through third parties who are developing apps and creating infrastructure around this data that's coming out. So, and at the same time, I don't want to undercut the fact that there are very sophisticated farmers, even in third world countries, who are able to use and access primary data. I had the privilege of talking to a few farmers in Kenya over the summer who were, as well as farming, in the middle of developing apps and using data themselves. So I don't want to dismiss that, but I think the focus here for usability really comes down to the fact that anyone can access this data. And as soon as anyone can access it, they can approach it at their level of skill and their level of ability to understand. And so that may be a third party who says, okay, I see this need in my community, and I have some skills to work with data, to program, and I'm going to build a tool to help the people in my community. Or it could be someone who is interested in creating a small business, or to developing some sort of app, something like Abelobi, that is designed to disseminate. Is doing this with, I think it was 5 different organizations that were building different ways that farmers could get an idea about what kind of market conditions there are, what kind of pests that they should be looking for in their communities. So this is really where the idea of an ecosystem or an infrastructure comes in, where this is not just scientists, it's not just farmers, it's not just the two of them. This is a number of people at very different places and positions within a much broader ecosystem around the world. And when we open data and make it available and accessible on the internet, then any one of those people can have access and use that data as they wish.
Yeah, so it all starts with open data. It's only then that actually people who could interpret the data and make it applicable and usable for farmers, only then they can have access. Very good. Thanks, Jeremy. Well, guys, we're coming at the end of this webinar. From my end, the next step will be to, first of all, aggregate the questions which were left unanswered. We'll pitch them to the presenters, and over the next week, I'll aggregate their answers, and you will get this in a follow-up email from me. it's a follow-up email. I will call it wrap-up number 2. But wrap-up number 1 will normally be distributed to all of you tomorrow, which will be a link to the uploaded recording of this webinar, a link to the uploaded presentation file. And somebody also asked me to have the links again to the recordings and the presentations from the last webinar that Juanita has mentioned. So these are the follow-up actions from me. But I would like Juanita to close this webinar. Juanita, where do we go from here?
Yes, thank you, Peter. And let me just congratulate all our presenters, because through their information and exchange of experiences, now we have seen how the world had changed from the business as usual. Now in validating other stakeholders, actors, systems that benefit and plays a very important role in food security and conservation of genetic resources, alleviation of poverty, and so on. So I think it has been very enlightening to see how we are talking about partners involving the informal seed systems, farmers with researchers, with the companies that produce sometimes data, important data. I think keep building this trust, keep building and sharing that information, and the processes of getting to those outputs is very important if we want to move ahead, fulfilling, for example, the Sustainable Development Goals, improving the livelihoods of the most vulnerable people in developing countries. And I think I will encourage everybody to keep, as I said, exchanging this information and moving forward in being creative in terms of how we can move from the certified system as usual to perhaps other ways, including other ways and forms of producing seeds, commercializing seed, guaranteeing the quality of those seeds that is again as valuable as and important as the formal and usual way to do it. So thank you all, and hope we can have other webinars to increase our dialogues in this issue and move forward implementing and promoting farmers' rights in the different aspects. Thank you so much.
Very good, Juanita. Thanks for helping to pull this webinar together. With the thanks also to our contingent of speakers, Jorge, Rose, Alejandro, and Jeremy. Thank you very much. Thanks also to Charles for the work behind the scenes in managing the slides and the complex mute management. I'll see you guys for the next webinars. You're now in our database, so you get an email when we have a next webinar coming up. So if you're interested, you can subscribe. See you all guys in the next ones. 2 more scheduled for October next month. Wish you good morning, good night, good afternoon, and see you for the next one. Thank you again. Thank you all.
Thanks, Peter.